Okay, so in this video, I want to do a couple examples of adding, subtracting, and multiplying and dividing with fractions. I noticed that in my college algebra workshop, a huge point of contention is working with fractions. How do we work with fractions? What do I do from here? How do I simplify? And so I'm just going to kind of work through a bunch of examples where I'm simplifying a bunch of fractions. So the first we'll start with the easiest kind of thing we can do with fractions, and that is multiplying them. It's really simple. Don't overcomplicate it, don't overthink it. Multiplying fractions, we just go across. So 7 over 3 times 5 over 2, I just multiply numerator to numerator and denominator to denominator. So that gives me 7 times 5 over 3 times 2, which 7 times 5 is 35, 3 times 2 is 6. And I can't simplify this any further, so I'm done, okay? Again, another example, 12 over 7 times 3 over 6. So I just go across. So I have 12 times 3 is 36 over 7 times 6 is 42. Okay, so I have 36 over 42. Now I can simplify this further because I know that each of these have a factor of 2. So I can divide top and bottom by 2, right? That's how we simplify fractions. 36 divide 2 gives me 18 over 42 divided 2 is 21. And so this isn't simple quite yet because 18 over 21 is also reducible. 18 is 9 times 2 and 21 is 3 times 7. They both have a factor of 3 is what I'm getting at. 18 divide 3 is going to be 6. 21 divide 3 is going to be 7. So what I actually had all along was 6 over 7. Okay? So, and the way I got there, I'll show you one way to think about it is, so to get from 36 over 42 to 18 over 21, 36 is 18 times 2. 42 is 21 times 2. These 2's will cancel and I'm left with 18 over 21. Okay? 18 is the same as 9 times 2 over 21 is the same as 3 times 7. And we also know that 9 is the same as 3 times 3. So I have 3 times 3 times 2 over 3 times 7. So I have this. Those will cancel. And so I have 3 times 2 over 7, which is 6 over 7. So that's another way to think about that. So we're just simplifying. Next, to multiply a fraction to a whole number. So this is pretty simple as well. We just kind of think, there's a couple different ways to think about it. One way is you just pop this multiplication in the numerator. So I have 7 times 12 over 2. Okay, that's one way to think about it. Another way to think about it is to think about 12 as 12 over 1. Right, because 12 over 1 is just 12. If I divide anything by 1, I get itself, so it's just 12. And I can go across like I did before, and I still end up with 7 over 12 times, or sorry, over 2. 7 times 12 over 2. Okay, and 7 times 12 is 84. And then I have 84 over 2, so this is 84 over 2. Okay, 84 is divisible by 2, that is 42. So what I actually have is 42. Okay. Great. Another way to get here is to have 7 over 12. So this 7 times 12 over 2 is the same as 7 times 6 times 2. Because 12 is 6 times 2. And these 2's will cancel. And then what I'm left with is 7 times 6. And we know 7 times 6 is 42. A bunch of different ways to get there, but we get there in any case. Okay, next example, negative 32 times 3 over 4. So first way to think about that is just to pop that negative 32 in the numerator. So I have negative 32 times 3 over 4. And, 32 is the same as 8 times 4. So I have negative 8 times 4 times 3 over 4. These 4's will cancel in numerator and denominator, and I'm left with negative 8 times 3. So negative 8 times 3 is going to be negative 24. Okay. So now that we have a good idea about multiplying fractions, let's look into adding two fractions. So to add two fractions, we have to give them a common denominator. We give common denominator. And the way we do that is by multiplying each of these fractions by something over itself. So I want to multiply, in this first example, 2 over 5 and 3 over 7 by something that'll give them the same denominator. So in this case, I'll just go ahead and do it. So I have 7 over 7 times 2 over 5, and then I want to multiply this 3 over 7 by 5 over 5. The reason I do that is because I notice if I multiply this 5 in the denominator here by a 7, and the 7 in the denominator over here by a 5, they'll match, right? Because both of these will be 35. I have a 7 and a 5 in both denominators now, as I'm multiplying across, right? But in order to divide something without changing the what we're looking at, I have to multiply by that as well, right? Because remember that for any number, a over a is 1. 5 over 5 is just 1. 7 over 7 is just 1. So I'm actually doing nothing, right? I'm just multiplying 1 to 2/3, which is just 2/3. So I'm not really doing anything, but this allows me to add my two fractions by doing what's called giving them a common denominator. Okay, so carrying out this multiplication, 7 over 2 is just 14. 7 times 5 is just 35, plus 3 times 5 is 15, over 7 times 5 is 35. So I have 15 over 35 plus 14 over 35 plus 15 over 35. Now, what I can do from this step is just put the addition in the numerators. 14 plus 15 over 35, like that, right? Because if they have a common denominator, I can just put the denominator under everything, and we can just add the numerator. 14 plus 15 is 29 over 35 is my final answer, because I can't simplify that any further. 29 we call prime. It has no divisors other than itself. Okay, so let's move on to this next example. So I have 2 over 6 minus 3 over 2. If I'm clever, I'll notice that I can multiply this by 3 over 3, because 2 times 3 is 6. So what I actually have here is 2 over 6 minus 3 times 3 is 9 over 6. 2 times 3 is 6, right? Multiplying across. And like we said before, we can just care about this addition in the numerator. 2 minus 9 over 6. 2 minus 9 is negative 7, so I have negative 7 over 6. And no more simplification can be done. Okay. All right. Now to add a fraction to a whole number, we can think about 7, and so looking at this first example, we can think about 7 as being 7 over 1, right? It's the same as 7 over 1, because if you divide anything by 1, it's just the same. So we can think about it as being 7 over 1, and then this reduces to adding the fraction 7 over 1 to 1 over 3. I give these a common denominator by multiplying the 7 over 1 by 3 over 3. And this, yeah, so this will leave me with a 3 in the denominator there. And I'll have 3 times 7 is 21 over 3 plus 1 over 3. And that gives me 21 plus 1 over 3, which is 22 over 3. And I'm done. Okay. Again, 10 minus 5 halves. So we can think about 10 as being 10 over 1. And I can give it a common denominator by multiplying by 2 over 2. This will give me 2 times 10 is 20 over 2 minus 5 over 2. That's going to be 20 minus 5 all over 2, which is going to be 15 over 2. And I'm done, because I can't simplify any further. Okay. Next, we're going to talk about dividing a fraction by another fraction. You may have heard of the kind of So next we're going to be looking at dividing a fraction by another fraction. So you may have heard of the saying keep, change, flip. And what that means is keep the top fraction the same. So keep the top the same. Change the division to a multiplication and flip the bottom one. So what that looks like, we'll say for this example, is we keep the numerator, so we keep the top one, so we keep this. So I have 2 over 3. I change the division to being a multiplication, and then I flip the bottom one. Flip the bottom fraction. So I have 7 over 5. And now we know how to multiply fractions. We just talked about it. We just go across. So I have 2 times 7 is 14 over 3 times 5 is 15. So I have 14 over 15. Very, very easy. Okay. So now, again, we'll apply keep, change, flip to this other one here. So we keep the top fraction. So we have 7 over 2. And then we change the division to being a multiplication, so times. And then we flip the bottom fraction. So I have 14 over 4. Okay. And then I noticed that I can rewrite this as 7 over 2 for the sake of simplifying things. This is 7 over 2 times 7 times 2 over 2 times 2, right? Because 14 is 7 times 2, and 4 is 2 times 2. So I can rewrite that just fine. And now I have these 2's will cancel in numerator and denominator. And so what I actually have is 7 over 2 times 7 over 2. 7 times 7 is 49. 2 times 2 is 4. So I have 49 over 4, right? Just multiplying that, these fractions across here. Great. And so this kind of, yeah. So next, to divide a whole number by a fraction. So again, we use keep, change, flip. We keep the top, so we keep the 3. So I have 3. I change the multiplication to a division, or sorry, I change the division to a multiplication, I meant. I have 3 times, and then I flip the denominator. So I flip this fraction in the denominator. So I have negative 9 over 17. Okay. Now we already talked about how to do something like this, right? I just pop this 3 up here. So I have negative 9 times 3 over 17. 9 times 3 is 27. So I have negative 27 over 17. And that's my final answer. Okay. Now to divide a fraction by a whole number, again, we use keep, change, flip. We keep the top, we change the division to a multiplication, and we flip the denominator. And you might think, okay, flip how? Well, remember that 6 is the same as 6 over 1. So we just flip that. So what I have, if I keep the numerator, is 12 over 5 times, and then flipping the denominator, I have 1 over 6. Multiplying across, this is 12 over 5 times 6. But for the sake of simplification, remember that 12 is 2 times 6 over 5 times 6. 12 is 2 times 6. And then I can cross out these 6's because I have 1 in the numerator and 1 in the denominator. And so I'm left with 2/5. And I'm all done. Okay. And now I want to take some time to kind of write out some rules here that happen in general. So in general, I'm going to give you some kind of like, I guess you would call them formulas. If I have, let me write this in a nice color. Let me write this in red. A over B times C over D is equal to AC over BD. I just multiply across. Okay? A times B over C is equal to AB over C. Right? We just pop this up here. A over B plus C over D is equal to AD plus BC over BD. I challenge you to verify why that is, right? This is the formula for adding two fractions. Okay, I genuinely challenge you. I want to see if any of the viewers can tell me why that is. Okay, dividing fractions, A over B over C over D is equal to AD over BC. Again, I challenge you to see why. And A over B over C is equal to AC over B. Again, I challenge you to see why. And A over B over C is equal to A over BC. Again, I challenge you to see why. But these work in general when working with fractions. These are the rules. For any numbers A, B, and C, D, of course, if it's in the denominator, it can't be 0. But this works in general for any numbers A, B, C, D. We'll say not 0. And I also wanted to take a second to kind of look at some examples that have variables. So I'll make some up on the spot here. So let's say I have something like x plus 2 over x plus 3 times x minus 2 over, I don't know, we'll say x minus 3. Why not? So this multiplication, again, this is just a multiplication of fractions. Even though it has variables, it's still a multiplication of fractions. And I just go across. So I have that this is going to be x plus 2 over x minus 2. Sorry, x plus 2 times x minus 2 over x plus 3 times x minus 3. And I challenge the reader, or I guess the viewer, to verify that this is going to be x squared minus 4 over x squared minus 9. Why? Okay? And to give you a hint, we would need to FOIL both the numerator and the denominator. Okay? And if you don't know how to FOIL, I have a video on FOIL in the College Algebra YouTube channel, or in the College Algebra YouTube playlist. So another example might be, let's say I have 1 over x plus 2 plus, I don't know, maybe 3. Again, I need to give these a common denominator in order to add them. That's what we do when we add fractions. I would multiply this by x plus 2 over x plus 2, right? Because then I have, popping this 3 up here, 1 over x plus 2 plus 3 times x plus 2 over x plus 2. Now that these have a common denominator, I can just do the addition above the denominator. So I have this over x plus 2, so I just put this addition in the numerator. And then, again, this will be, and I challenge the viewer to discover why this is going to be 3x plus 7 over x plus 2. All right, and that kind of wraps up what I wanted to say about fractions. I think we did a pretty comprehensive work through of some examples with fractions. If you found this video helpful, please consider liking or subscribing, and thanks.